Hello, so we're going to be using the integral test to solve two problems. The first problem asks us to determine if the series from 1 to infinity of natural log of n over n is convergent or divergent. So we can use the integral test, and in order for us to kind of check and see if we can use it, we can check to see if this is continuous, positive, and decreasing interval from 1 to infinity. And if it is, and we use the integral test, and we find that we get a finite number defined by n, then this is convergent. If we get an undefined number like plus or minus infinity, which is infinite, then this is divergent. So in order for us to check to see if our function is continuous, positive, and decreasing, we need to do each one of those things individually. So first we're going to check for if this is continuous. So we have natural log of n over n, and when we're doing this, we're kind of just going to check to see if there are places where it's discontinuous. So a natural log of 0 over 0, this is discontinuous because this natural log of 0 gives us an undefined number, and so if it's undefined, this is where the function is discontinuous, as we learned in Calc 1. But on the other hand, we only care about the interval from 1 to infinity. And so this isn't on the interval of 1 to infinity, so this is not really important to us right now. So we're going to check at n equals 1. So we have natural log of 1 over 1 equals 0 over 1, which is equal to 0. And so at 0, this is not discontinuous, it's continuous. So yes, so now we can check to see if this is positive. And so we can just kind of look at this and talk about it a little. So natural log of n over n, there is no there's no value that's positive where it's gonna make natural log of n negative or n negative. So since both of these are just positive separately, the numerator and denominator, this is positive as well. And then the last thing we need to check for is if this is decreasing. So we can use the a sub n is less than or equal to, or is greater than or equal to, less than or equal to a sub n plus 1 rule, and if this is true, the function is decreasing. So we can plug these things in. And so we can see here that, yes, the function is decreasing. If you're unsure about this, like when you look at it, because sometimes questions can kind of make you confused, you can also take the first derivative of your function of f sub n, and if your derivative is negative, then your function is decreasing. We can just kind of think about that in terms of slope. If your slope is negative, then your function is probably decreasing. So that's kind of a good way for us to think about it. So since we see that all of these things are true on the interval from 1 to infinity, we can now use the integral test. So we have the integral, so 1 to infinity of natural log of n over n. So whenever we have integrals, we use x. We're just going to do this for the sake of being organized here. So you have 1 to infinity natural log of x over x dx. Now, wherever you see an infinity sign, replace it with a t. And so we're using the improper integrals kind of methods here. So it's 1 to t natural log of x over x dx. So this is kind of weird looking. We can't just solve this, so we can use u sub, and we can allow u to be equal to natural log of x and du to be equal to 1 over x dx. And so when we plug this in, these cancel, and so that's why we decided to use these specific values so that we could cancel this. We have to remember within every step that we do, we carry the limit so that it's not forgotten about, because it's always still there. So here we have the integral from 1 to t of u. This should be a du. And now if we just integrate this, we get u squared over 2. And so we remember that the u we chose is equal to natural log of x. So we can just plug that in now. Natural log squared of x over 2. So the limit as t approaches infinity of 1/2. We're going to just take the 1/2 out so it can be easier for us to solve. Natural log squared of x from 1 to t. And so that gives us natural log squared of t minus natural log squared of 1. And so like how we mentioned in the beginning, natural log of 1 is equal to 0. So natural log squared of 1 is also equal to 0. So now we just have the limit as t approaches infinity of 1/2 natural log squared of t. The natural log to infinity is equal to infinity, as we know. So the limit as t approaches infinity is equal to infinity. 1/2 becomes insignificant when infinity becomes a factor in the problem. So the next thing that we know is from the beginning, we'd said that if we don't have a finite number when we take the integral test, then this integral diverges. So by the integral test, the integral diverges, and so therefore also the series here is also divergent. Okay, so the next problem that we're going to go over is number 2, and it asks us to determine if this is true or false, the statement. The integral from 1 to infinity of 1 over x cubed dx and the series from 1 to infinity of 1 over n cubed are both convergent to the same value of 1/2. So the thing that we can use here, which is also covered in the integral test section, is p-series test. So the p-series tests that a series of 1 over n to the p, where p is greater than 1, it converges, and where p is less than or equal to 1, it diverges. And so it was also similar to the other test that I mentioned in the first question, is that if the series converges, then the integral also converges, and also if the series diverges, the integral also diverges. So in our problem, we notice that we have this integral or series 1 over n cubed, and we have this 3, and it's set up in the same way. So we can see that p is equal to 3, and based off of these rules where 3 is greater than 1, the series converges. So that means that this particular series is convergent at 3, and also the integral converges at 3. However, this still makes it false because it's asking, does it converge at the same value of 1/2? However, according to the rules given by the p-series test, if our p was equal to 1/2, then this would only diverge. So this is a false statement, and it converges at 3.